Hi, everybody, and welcome to the inaugural meeting, first ever of the KCP Edge community. Thank you all for joining. We're hoping to have a very vibrant and thriving community started as a result of this. We're focused here on Edge multi-cluster related use cases, and we basing most of what we're working on today on the base KCP technology that's come about in the open source community. So we feel that's a strong basis to start from, and we'd like to continue to embellish and augment that as possible for purposes of upstreaming that to KCP, as well as if we're in the future, if it gets absorbed into Kubernetes, we wouldn't object to that either. In today's meeting, we'll be discussing the the KCP Edge and its inception and its driving concerns. That'll come at the bottom half of the hour. But up front, I wanted to get some feedback from everybody here on the call for some base logistics. Once these are out of the way, I don't suspect these will be recurring topics. So then we can get to the meat and the subject matter that we'd like to cover. So first up in logistics, we have the name SIG or the modifier SIG on our title for SIG KCP Edge. Wanted to know if that's something that we feel is acceptable because it connotates that we're part of the Kubernetes community, or if we should drop the tagline SIG and just default to KCP Edge community. Does anybody have any strong preference? Please raise your hand if you have any information you'd like to add. I'll call on you. Andy, thank you.
Uh, SIG just stands for Special Interest Group, so I don't feel like there's a problem including that as part of the name. Just my 2 cents.
Okay. So let's put a vote. Does anybody object? If I don't, by raise of hand, does anybody object to using SIG in our title? All right, ratified and approved. We'll continue to use the term SIG in our title. Thank you. Okay, secondly, these are a little bit more involved. So GitHub location for code. So we wanted to know, there could be the potential for several different efforts ongoing simultaneously in the work that we'll be talking about with EMC, with sharding, and all that comes with EMC, potentially, schedulers, different syncers, etc. So wanted to get a feeling for the community's suggestion here in terms of GitHub. Should we continue to use what KCP affords us in KCP Dev, or should there be other GitHubs started accordingly? Please raise your hand. Ezra.
So I think coming from the last call we had with Stefan and another, I think that as far as we go with the EMC layer, right, we talked of doing some kind of similar architecture like the separation of TMC from the core KCP, right? So that part should go to whatever Andy and Stefan think that those repositories should go. I would say maybe KCP dev slash. What did you have in mind regarding TMC? Is it going to be
Also, Andy,
KCP dev
so
slash?
yeah, can I also add, Andy, remember, KCP Dev is an organization, not a repo.
Right.
KCP Dev slash KCP is a repo.
Right. So do we want to just put I think the first question is what are your plans regarding the TMC separation? Where are you going to put the TMC kind of repository, and is it okay for us to put an EMC repository in parallel location?
All right, thanks, Ezra, for the questions. Andy has his hands up.
Yeah, so we're gonna create a repo called TMC for the transparent multi-cluster bit. I wouldn't call what you're doing with Edge EMC, just given the company name. I would just call it Edge or something like that. And so we'll do another repo for this.
Oh, great. Yeah, we try to maintain kind of similar names, but you are correct.
How about Edge? How about Edge MC then? I do like the name, when spelled out, Edge multi-cluster, because it makes the parallelism with transparent multi-cluster really clear, and I think that's appropriate.
But Mike, isn't it a fact that everything under KCP organization is basically multi-cluster, right?
I don't know. I don't think we need to take a position on that. I think the obvious choice is another repo under KCP Dev, and I think Edge MC would be a great choice.
So we can vote on the name, but I think that the bottom line about repository is that we can open a repository under KCP Dev for the Edge layer, right? Is
Yes.
that what you meant, Andy?
Yes.
Okay, thank you. By the way, do you have already open epics or concrete plans for the TMC separation?
We've started discussing it, but we don't have a timeline.
Okay.
Ezra, is your hand still raised or are you done? Okay, great. Thank you. All right. So if I've captured that correctly, TMC is going to be carved out of the KCP repo and Edge repo to be started. So at which time the Edge repo is started, I'll start putting these agendas and the epics in that repo. That'd be great. Okay. Any other comments on the GitHub location? Okay. All right, Slack location. So we know there's a pound KCP dev. Do we want to fork from that, or do we want to stay in there and just use titles? Is it okay to use that Slack channel? We don't have a preference necessarily. What does the community think?
Yeah, I'm fine keeping the conversation there unless and until it gets too distracting from other KCP core conversations.
And I actually prefer it to be still in KCP Dev and in the regular KCP until we have critical mass, because we may attract people that do not belong to, and want to participate and answer and so on. So
Yeah. Does anybody have any objection to keeping the conversation at KCP Dev? Okay, ratified. Thank you very much. Next one, Google Group mail distribution. So we know that there's always a KCP Dev Google group that we were asked to remind others and adjust and add to this email distribution for this meeting, which worked, I think, very effectively. So thank you very much for lending us that. Can we continue to use that and simply just qualify with KCP Edge for those of us that are be sending out messages on our chair's behalves? Does anybody have an objection to that, or would you like us to form a new Google group?
Same response for the Slack conversations. Like the mailing list is not high traffic right now, so we'll split if we need to.
Excellent. We appreciate that. Thank you. All right, the logistics business, I believe, is concluded, so we can turn our attention over to the driving concerns for Edge. And with that, I'll turn the floor over to Mike, Ezra, and Paolo to give us an overview of the driving concerns. If any of the three of you would like to share the document that you've prepared for this presentation, or if you'd like to, I think it'd be good if you shared the document, but I can bring it up.
I'll do that.
Here.
Yeah.
Yeah.
I'll do that. Also, by the way, I don't have permissions to create repos under KCP Dev.
I'm doing it right now.
Thank you very much. All right. Let me try to share that document then. Okay. All right. So, we tried to organize some thoughts, shared it with the community. We started to have some discussion already. So I tried to organize this as some driving concerns, and then there's consequences. There are really a lot of consequences to tease out, but I think it's important to recognize that there are really some fundamental differences that are driving this. And I'm still learning about transparent multi-cluster. I don't fully understand it. So I'm just going to kind of use that as a springboard to really, I think the important thing here is just to be clear about what we mean about edge computing. So I might call out some differences that are not really differences. But anyway, here we go. So one of the, and I'm not quite sure how to really, I'm not sure I really got the right phrasing or framing of all these things. But my impression of transparent multi-cluster is it really focuses on a scenario supporting a user who basically wants to use a Kubernetes as a service, and they're developing containerized workload, and that's all well and good. In edge computing, customers, of course, have the full stack problem. They own typically, the customer is an enterprise that brings edge locations. They've got a business with edge locations, and actually generally some kind of physical hierarchy in their business, and they bring that to the table. And they've got problems of infrastructure, which you might describe with words like infrastructure and platform, as well as the containerized workload. So there's kind of a different slice on it. Of the customer, in some sense, in the first instance, owns the full stack problem. Another is that the edge locations may be small in terms of the compute, network, storage, memory, that kind of underlying resource involved. In fact, when you talk about edge, people also will often put IoT in the same breath, and IoT really stresses kind of small devices. I think here we don't want to go all the way to the smallest possible device. I think that for edge multi-cluster, we want to terminate at the cluster point of view. Say, okay, we're going to say that each edge location can run a cluster. It might be a small single node Kubernetes cluster, but it's still a cluster. In TMC, I believe there is again, because of the focus is on Kubernetes as a service, the idea is that as I understand it, and I may be getting this somewhat wrong, the user focuses their attention on one or a few namespaces. I notice, the placement, for example, refers to namespaces. Again, in the edge scenarios, it's really a full stack problem, and there may be non-namespaced resources that are important here too. So it's anyway. Okay, let's move on. As I said earlier, customers bring their own business physical hierarchy. It's not like we are going to design a service that works for all the customers. We might be able to, work on some central thing, some central service that some customers can use. A lot of customers do actually have, for various, sovereignty issues, they won't want to use a service. They'll want something on-prem all the way. Some may be able to use a shared central or multi-tenant central service. Customers doing edge computing generally have a more complicated arrangement of roles and responsibilities. In TMC, there's kind of a focus on a DevOps sort of scenario where the primary user is, developing and operating something. But in edge computing, it tends, not always, but it can be much more complex. A similar DevOps sort of scenario might be, say, a retail operation, some kind of a retail chain where there's a corporate engineering group that is doing DevOps, and they are in charge of what runs at each store. But maybe consider manufacturing, where there's maybe like a auto manufacturer or a chemical refiner, or they have many plants. There may still be a corporate engineering team that's doing some level of central engineering, and they're in some sense at the top of the pyramid. But there's also plant managers that have authority and need to be involved in decisions about what happens in their plant. And it's another kind of example that we're all familiar with. Think of your laptop or your phone. Smart phones are really common examples. Think of all the things that are involved. if you've got an iPhone that you use for work, right? Apple's got some authority. You probably bought that phone from a telco like Verizon. They have some authority. Your employer has some authority, and you have some authority. So, we often have, these more articulated, complicated scenarios. And now we get to one of the really important driving scenario concerns. The number of edge locations can be large. Not, it may not be. In fact, there's a lot of customers that don't have a lot, but we do aim to ultimately cover cases where there are a lot. Again, if you think about, say the cars or cell phones, you quickly get to very large numbers. We need to walk and crawl before we run. But that is part of the vision. All right. Now, also coming with in that, the next concern is that this multiplicity. In TMC, each placement object directs one copy from the hub workspace out to some P cluster. In Edge, we wouldn't want to have to create a placement object for each edge destination or edge location. I want to say also an edge location, may have more than one cluster, but it will. I think I'm willing to draw a line that says it has at least one cluster. But anyway, we wouldn't want to say that the higher level stuff, whether it be administrative users or higher level automation, has to directly maintain a placement object for every edge destination that they want something to go to. You want a more compact statement. You notice, for example, in transparent multi-cluster, right, the placement has a predicate that says what locations are acceptable, and the semantic is pick one of them. In Edge, you want something more like pick all of them. You want to be able to say compactly, this is all of the places I want this stuff copied to. Now that has some knock-on implications that are, TMC does not attempt to address. One of them is the status. The status, obviously each destination has its own status that needs to get reported back somehow. And the standard status sections of the standard object types, they're not intended to represent status from many copies. They're intended to represent the status from one copy. So there's a semantic mismatch there. Also, again, the higher level stuff typically doesn't want to just deal with thousands of individual statuses. It wants to deal with a summary of some form. So there's an additional issue of defining how to do the summarization, how to represent the summaries. Also, there's a more subtle, but I think really important thing that comes out on the spec side, which is, again, when you have talking about this one-to-many distribution, you often find in edge scenarios that you need to do, or the customer wants to do a bit of customization for each edge destination. So the copies need to vary a little bit and be personalized or individualized to the destination. So those come out of there. Now, when you combine those two previous issues, you get a lot more things that come out. When you deal with the fact that there's this one-to-many distribution and the many is large, some of the solutions that would work if the many was small, just completely unworkable. And you have to deal with some additional issues. I tried to list them here. As I mentioned, one of them is the need for the compact representation of where you want, or the customer wants one thing from the center to go to. And I kind of, outlined my thought. Basically, it's a takeoff on the TMC placement. We can make an edge placement that is a lot like the TMC placement, but the meaning, the interpretation of the predicate is pick all, not pick one of the things that satisfies it. Let's see, another one, again, this is about the customizations. When the number is small, you might be able to do something like maintain a customization with a K .yaml file for each destination. But again, when you have a large number of destinations, that becomes unworkable. You need the customers really need a way to describe with one pattern how something from the center is to be customized for each of the many destinations that it goes to. So you need to be able to, some way of describing customization with a pattern that has named parameters that take on different values for different destinations. Let's see, again, the summarization of status becomes critical. Nothing higher level wants to deal with thousands of individual statuses. In the first instance, of course, when there are issues, problems, typically there will be some need for some ability to find them, find which destinations have trouble, and B, investigate it. So there often is a desire to have this somewhere in the center, as well as have a summary in the center. Another thing that comes when you have this compact description of saying one copy in the center gets distributed to many destinations is now you don't necessarily want all the destinations, all those copies to be at the same time. Particularly when you're dealing with changes, you'll often want to do some kind of rolling update. And this is where things like canary testing and blue-green testing appear also. Typically, enterprises doing edge computing will want to start by deploying a change in just a few places, do some evaluation before continuing to roll it out. So there's a need this just brings in the issue of controlling that rollout. And then also, a little more subtly, and this is not a matter of really interface to the higher levels, but just in comparing with TMC, as most of you are probably aware, in TMC, there's a distinction between a scheduler and a syncer, and the way they communicate is with labels on namespaces. So for each destination that a namespace should get propagated to, there is a label put on that namespace. And that works well when there's a few, but if you get to the thousands, that just is unworkable. So we need a different sort of interface between scheduling and syncing, if we even maintain that distinction. And I think it's plausible to maintain that distinction because it's a useful kind of modularity, but we need a new kind of interface there. Another one is, I'm actually going to say it this way. In many edge, I'm not going to say all, but in many edge multi-cluster scenarios, it's desired that each edge location be able to operate independently of others and of the center. One motivation for this is the connectivity. The networking may not be consistently good. Sometimes it's absent. Sometimes it's slow. In some scenarios, it is sometimes slow and sometimes fast, or sometimes present, and sometimes absent. And generally, we don't rely on in edge computing. You don't generally can't make the assumption that there's usually good connectivity between edge and center, or between edge locations. There are other motivations for this. For example, a data sovereignty, or regulatory, general regulatory concerns. So I think the driving desire here is to enable each edge location to be able to operate independently. And again, as a driving concern, this has some implications. So the health checking that's in TMC is not appropriate because it assumes that usually the connectivity is there. And also TMC wires each container in a P cluster. When it talks to an API server, it's talking to the API server back in the hub cluster. And that's not what we want in edge. We want all the communication local within an edge location. So I'm going to stop there. I've probably gone on way too long, but that's just a brief zoomy overview. And I did make some specific API proposals for some of this, so people can look at those. I shared them with the KCP dev mailing list. Anyway, I'm going to shut up and take remarks.
Paulo and Ezra, anything you want to add?
No, I think that it all kind of boils down, even after the first or second it's kind of, I see it as kind of incentive to why we think we indeed need probably a complete different layer, right? We need different thinker, different scheduler, different place and policy and so on, and we already discussed it last call. And we probably, when we go to each of those, we will need to come with probably with this community, with a more specific requirement list, right? What do we require from the thinker in that case? What exactly do we want to think? If we take into account that we are disconnected and so on. So I see that list as kind of initial requirement list plus incentive if someone actually thought that we may be able to go with the existing TMC component. So this is kind of a lot of reasons why we probably shouldn't. And I think it's already agreed last time.
Yeah, I agree with Ezra that probably what we really want to do is to somehow boil down this to a sort of a set of requirements that really impact the existing TNC. Actually, what we need to add to build the new Edge multi-cluster service. So we probably have a parallel set of components. So I can imagine that we're gonna have a scheduler for Edge. We're gonna have a syncer. Maybe, I don't know, maybe we can reuse the existing syncer or modify it for what we need to do here, but will be probably a different syncer or maybe a configurable syncer. And then, of course, we're going to have maybe this new set of APIs for placement and so on, because, of course, the behavior is different. I think we discussed already that probably we don't want to use the existing placement, for example, to deal with Edge because the behavior will be different. And so maybe it doesn't make sense to try to extend that, but maybe we should have a specific API for that, right? So I think eventually we want really to have a list of these components and what actually each one of them does more in detail before even we start implementing them.
Yeah, I think that practically, Paolo, we mentioned that we can start with just copy, kind of duplicate the TMC layer and start from there as our layer. I think the main question along the whole work will be what are the required changes in the core KCP layer, if at all, and try to minimize them. And for that, we will need to interact with the KCP people. But, any special comments from Andy, Stefan, something? I think it's high level currently, right? Not.
Yeah, I mean, I'd say at this point it's kind of wait and see. Like as there are more explorations that the group does, if you run into problems with the core of KCP, like we'll see what changes may need to be made at that point. But it's really hard for me to say, yes, I foresee X changes right now.
Right.
Well,
Bob touched on one thing very specifically here, which is we have called out some need for different syncer behavior. So, one of the top questions on my mind is the one Paulo said, right? Do we want to have a different syncer or share a configurable syncer?
I would try to find commonalities and put them in a library and then have different syncers, most likely. But that's the sort of thing that as more research is done, I think it really comes down to, are there actually commonalities or not? So that's my very it depends answer.
Mike, I think that we even haven't defined fully what exactly we want to think, right? Especially
You're right. It is early days. It is early days. So maybe we just come back to this later after we're more defined.
Yeah, one point we didn't touch was about, we talk about scale, right? So at some point, I think we need also to think, how do we start sort of testing for scale in a way, right? So I don't know how much of this kind of testing was done so far, at least for the TNC. For example, I know that the goal is to have a lot of workspaces. We're talking about 1 million potentially with sharding and so on. But I wonder, we need at some point to be able to sort of have a large number of physical cluster, or maybe to have a way to simulate these physical clusters, right? And so that we can also connect to a set of sharded API KCP servers, a large number of sinkers, and this sinker connected to this physical cluster or edge clusters. And so I wonder if there was any effort so far in the community to try to somehow simulate a large number of sinkers, for example, to do some kind of stress testing on the KCP side of things. On the
Let me just add to that even another question, because this is something we were planning to work on, even on the normal without the TMC, right? I was looking at the code, and the initial promise was, workspace is a lightweight thing, zero cost, you can open quickly millions, but as time goes on, there are workspace-based controllers suddenly and so on. And I was wondering if someone at all did some large-scale, even just workspaces, right? Performance test, how much time it takes to create the 100,000 workspace and so on. And is it interesting if we will do some kind of large-scale performance test on KCP?
Remember, Dave Festel brought this up in another call that we had with I believe it with the smaller group of folks from the community about using workspaces, specific controllers, etc., schedulers, etc.
This hasn't been done much. There is big interest to do it. We are at a stage where you must know what is just not implemented. So there's not much value in just blindly testing what we have. Like the sharding work, it's very much work in progress. We're getting nearer to something, but we still have steps in front of us. Testing workspace creation is something, just try it and find out where the problems are. And I think everybody is happy to see improvements. So I think the focus should be tested, like stress test, but also contribute improvements, which gets us higher in the scale.
You mean not just identify the issues, but also commit to fix them, right?
We just know that
sure.
they're not there, right? I mean, Kubernetes needed years to get to 5,000 clusters, right? Everybody knew in the beginning it was scaling up to 100. We knew what to do in Kubernetes, and we're at the same stage, right?
Yeah, and
which
I can
reminds
say
me.
that one of the incentives for KCP, by the way, is the fact that working with 5,000 nodes clusters is not really easy, right? We actually want to break into many, many different kind of small clusters and workspaces. So the fact that they are not doing it very well is actually a good thing for KCP.
That we can horizontally scale just by design, which
Right.
Kube cannot.
And in any case, it looks like there is value in doing some kind of stress testing to find bottlenecks and issues that, of course, also helping to fix them. But in order to find them, we still need to do this kind of stress testing or large-scale testing in some way, right?
Yeah, everything around workspaces, everything around API bindings, I think would be interesting. And find issues, improve it.
Also, assume that, especially for Edge, right, we end up having potentially a large number of physical clusters connected to one shard at least, or multiple shards. And in that case, I don't know, that's also a scenario that maybe is slightly different than TNC, where we may have a lot of sinkers somehow hitting the same API server instance. And that's something that we need to figure out how that will behave in that case.
Mike, you have your hands up?
Yeah, part of the question here, I think, for testing is, are we talking about a test that somebody runs once, or is there some CI framework to contribute this to so that it's run regularly?
I think that there is already, they have E2E test, and I think it's a good question. What are the performance and scale tests that you want to add into the ETA test cycle in CI/CD? I assume that usually you do not run it on every PR or but maybe every major build, right? To see that you didn't compromise your performance.
So upstream has those 500 Node 500 tests or something, which you can start manually to some command on the PR. Would be interesting, of course, to have this automated, or at least in a makefile target or something, so you can run it.
So it's through Proud Jobs. They do it regularly through the CI/CD.
Upstream, I think so. Yes.
Oh.
Yeah.
But it's not mandatory for each PR to run.
No,
that,
it's
right?
not. It's not. I think they run it before releases, obviously. And if you know there is something very deep foundational you change, then they run it. And it's super advanced, like they really have. I mean, they have worked on that for years. You notice that.
But these are not kind of stress testing or performance testing. It's probably more functional testing or feature
Yeah,
testing.
they have those virtual kubelets, for example. They are not real, but they simulate a kubelet, and they can simulate 500,
So in
even
Kubernetes,
5,000, I think.
there are a few different kinds of tests. There are some tests that are run on every PR. There are some tests of those, some are required to pass and some are not required to pass. There are other tests that are run periodically, not on a PR basis. And I think there are some that are not even in that category. So, that's part of the question here is, you know, what's the story and what's the prognosis for the coming story in KCP for these things? And the other part of the question is the infrastructure to run the tests on. It's one thing to have a makefile target, but what are we assuming runs that? And does that makefile target or whatever just use the one node it runs on, or can it spin up, VMs or whatever to make a large system?
Do we really need to, come to a conclusion now, Mike? I think Paolo's
No, of
question
course not.
originally
My
was
point is just that
wait,
I'm
I
just
think
saying.
Paolo's question was practically, how do we, are there any, how do we do very large kind of tests where we need large number of physical clusters for the sync and so on? We probably need to think about it.
Yeah, well, my thought was we don't necessarily need to have real physical clusters. Maybe there are ways to simulate the physical clusters. One example could be simulating them with actually workspaces. But the other
We can
problem
try
is
to do the synonym for virtual kubelet, which is for nodes. We can do virtual something for clusters, right?
right, because all we want to stress is the interaction somehow between the sinker itself and the center, the KCP API server on the center. That's what we're really stressing. We're not trying to do anything really real on those physical clusters, except maybe deploying or simulating the deployment of some resource there.
So basically, the
idea was to see if we can come up with some kind of framework or some simulated syncer or set of syncer that I think this is something we did in our own internal POC, right, for KIST. We actually have these simulated agents. We can run a lot of them, and they put stress on the center, and that allow us to figure out what is going on there. And I think Mike did a lot of interesting findings in finding bottlenecks and performance issues, stuff like that. And that can be very useful. We don't need necessarily to create for real 10,000 real Kubernetes cluster to test this stuff, right? I see there is a hand, Stefan.
It's an old hand, I think.
It's an old hand.
Okay.
yeah, especially Paolo, if we do not test it on thinking of deployments where you actually want to deploy something, because you can sync whatever you want, right? Just a simple CRD or whatever.
Yeah, but I mean, it can be a sync, it can be even a deployment, but even the target doesn't need to necessarily react. It doesn't need to have a controller there to do anything.
Exactly. Deploy it, yeah.
Well, since we're interested in status coming back, I think we want to sync something that will get a reaction.
It's up to you. You can mock return statuses, right? Randomly even and so on.
One thought
Indeed, I
also,
think there's a range of possibilities here, right? I mean, we all looked at a blog post from Rancher a few years ago where they went through basically 2 levels of simulation, to get to their most extreme scale. They did not do the real thing, out from the center at all. They had something that just simulated the behavior of the peripheral thing. Um, and then before that, though, they did something that was a little more real. And I think we probably will want to end up doing both. One for really high fidelity and one for really high scale.
So, going to something else than performance, I was just thinking, if we're actually creating this edge layer and we are starting by saying, oh, let's duplicate TMC, aren't we basically doing the TMC separation through this work, right? Because we are building a new layer, which is actually including the original TMC components. And this is basically what you try to do in the TMC separation, isn't it? Right? This is probably to Stefan or Andy. If we start with an edge layer that is basically a duplication of TMC, and we start to change that, we basically started with the separation of TMC, which is what
You could definitely start with the syncer, like if you want to help to get it out into the new repository, and then make a copy.
Okay, I got you. Okay, so you mean, I didn't think about that.
For
So
the
you mean,
for the syncer, I think it makes sense. For the
okay,
APIs and controllers, not so much. They are different.
okay, so I got you. So you mean even in the layer, just start with a single model. Okay, got you. Okay, so start with only the syncer.
Yeah, I would do that because this is obviously a different component and easy to move out. And we can use that to bootstrap. I don't know. We need Pro, for example. We have to build this thing. We have to build images and everything. So we can basically do the same thing in parallel twice. That might make sense. I know.
And I think we'll need our own placement, data type, from the start.
I wouldn't copy too much from the controllers in the API. Take one of the API groups, modify it, sure. But the
Exactly.
APIs at the end will be
Take
different.
it, modify it to what we need.
there are a few other resources also that are relevant to TNC, right? There is the scheduler part. And there are also API definitions, like the current placement location, for example. Maybe we're gonna reuse location, we don't know, but probably placement is something that maybe.
Yeah, those were meant to be generic. I'm not sure how really generic they are. You will find out.
Yeah, so
Yeah.
far I have not seen a reason to diverge on location and sync target. I think they should be usable for edge as well.
Okay.
Yeah, it's probably placement that is the one that may have a different semantic, the way you will behave, right?
Right, it has a different semantic for that namespace for that location selector. And also it needs to be able to point to non-namespaced things as well as namespaces.
By the way, was there any plan also in TNC to somehow support also non-namespaced resources, or the idea is only to do this very, very selected subset? Because I think there was at least one.
I think I saw a PR on that even somewhere.
Yeah, so right now it's on a case by case basis because there's no easy, deterministic, repeatable way to identify what belongs to what workspace versus physical cluster, and how do you resolve potential conflicts if you've got two cluster scoped things that you're trying to sync down to the same physical cluster. So we know that we want to do it with persistent volumes, and there are design efforts to make that work between workspaces and physical clusters. I think we would need similar use cases and R&D to figure out what other cluster scope things we might be syncing back and forth rather than trying to open it up to everything.
Are there any? One thing, Andy, if we have time, maybe we can have like a few minutes that Stefan can share with us any feedback he got in KubeCon regarding Edge and KCP or whatever, if at all.
Not really about Edge. I mean, I was mentioning that in, I think even in 2 talks, but nothing concrete about that. I think we had, in general, I think we had good feedback from many companies, even big ones from the cloud business. And it really helped to show KCP not as TMC, like this bundle of things, and also not with hierarchy, but really as a very generic tool, which can be used for many, many things. And we heard from a couple of people just moving out compute and replacing it with something else, like this edge topic you are working on or something else. That resonated. So also in the multi-cluster area, it would be interesting, like the multi-cluster area more like in a Google Cloud setup where you have many clusters in GKE and you want to schedule something like one application, one big game backend or something. You want to distribute that to many clusters. Even that would be interesting to replace the compute of Cube. So it's a generic pattern, it seems. Anything else, Andy, feedback-wise?
I don't recall hearing too much feedback myself around Edge and multi-cluster at KubeCon. I think most of the talks and chats I was involved in were around binding and workspaces.
So in KubeCon, in case of KCP, put aside Edge, what from your kind of view, what was the kind of killer use case that people relate to KCP with? What was the main kind of traction to KCP?
That was the point. We didn't focus on one use case because our trouble in communication before, it was always that we presented 1 or 2 use cases, but people had different views. And when you ask them, like when we ask them independently, what do you think KCP is and what does it bring to you? We heard different things, like completely different things. That's why we generalized the discussion into this is, so I use this KCP machine metaphor, right? So it's like a Turing machine, but it's KCP, it's distributed and it has controllers, so controller logic for the workloads. This was a style we presented that. So and then basically the task for the audience, if you have this distributed thing and scalable and everything and bindings, of course, and workspaces, what can you build? That was a question to make people think what are their use cases.
Great.
Okay. And I think any of the other topics we choose to cover at this point would be too big in nature to fit within the time we have left. So if anybody has any closing remarks they'd like to make, otherwise I'd like to close the meeting. Anybody have any remarks they'd like to make? Okay, folks. So thank you, Andy and Stefan, for creating the repository for us, Edge-MC.
Wait a minute. I'm sorry. I thought you did have some more questions, Andy, that we did not answer, like some kind of future get together. Is there some meeting cadence or discussions you want to have?
Yeah, sure. Certainly, yes. I was going to remark on that. So we have a biweekly meeting cadence that we've established. It'll be every other Thursday. Next meeting will be on the 17th. And so, Mike, just as you were making that comment, I was leaving it in the chat There is an issue link for the new repository with issue number 3. So I've copied over issue 1, which was the original Epic, issue 2, which was today's meeting's agenda, and issue 3 now. You feel free to add any topics or discussions you'd like to put there. Andy, as a note, I'll be closing out the two tickets that I have residual in KCP Dev, or it's in the KCP repo.
I
that
can
refer to-
transfer them if you want. Or
Yeah, let's move them. Let's move them to the new repository. And by
Sure.
the way, I wasn't here on the beginning. 1 minute. Are we going to move this call to Google Meet and not WebEx?
I'm going to keep it in WebEx for now because it doesn't afford me the flexibility to use my mobile phone if I need to open the
So
call.
just remember, everyone, that I think we cannot save the chat. So
Yes, you
everything
can.
is.
Yep.
oh,
Can you?
I never post the chats for the KCP community meetings. It's
Okay.
just like an extra hassle I don't want to deal with. So I only post the videos.
You even get like nice little wordles and everything
Oh,
out of the transcript. Oh, it's exciting. Anyway,
it was new.
I won't bore you with the overhead. Andy, thank you for being so capricious and helping me through the first meeting.
So I'm guessing you'll get the recordings, Andy, and want to post them up on YouTube. Let me send you a link to get you access to our YouTube channel. We can either create a new one just for Edge discussions, or we can just put them in the channel that we have for KCP community meetings. Either is fine with me.
Maybe you can
Yeah,
put some prefix, the same prefix as the mailing
Yeah.
list, right?
I was thinking we'll stay in the KCP vein if that's okay with you.
Yeah.
I don't think we're big enough rock stars yet to go out on our own. I'd like to stay with you guys if we could.
Yeah, all right. Let me I'll DM you a link to get in there.
Thank you everybody for your attendance, and I look forward to hearing from you again in 2 weeks. Please contact the team on Slack if you need to discuss any subject matter between now and then. Thank you.
Thank you all. Bye-bye.
Bye.
Thank you.